Hello everyone, welcome to my presentation. My name is Shitok Shaha. My ID is 241333071, Section B, Batch 241, Department Electrical and Electronics Engineering. My topic name is Nodal Analysis, Thevenin Theorem, and Mesh Analysis. First of all, talk about nodal analysis. Definition. Nodal analysis is a powerful technique used in electrical circuit analysis to determine the node voltage in a circuit. By applying Kirchhoff's current law and at each node, we can set up system equation that can be solved and find the unknown voltage. Key concepts. Node. A point in a circuit where two or more components are connected. Reference node. The node assigned a voltage of 0 volt. Node voltage. The electrical potential difference between a node and the reference node. Kirchhoff current law. Here's come the algorithm. Define nodes. Identity all the nodes in the circuit which are connected conductive segments. Select a ground node. Choose a node as the reference node. Usually the one with the most connection. And the voltage of the ground node is defined as 0. Assign variable for each non-reference node. Assign a variable to present the voltage at the node. Write node equation for each non-reference node, or write a KCL equation that set the sum of the branch currents to 0. Combine voltage source. If two unknown voltages are connected by a voltage source, combine the nodes into a supernode. Solve the equation. Rearrange the equation into matrix and solve the unknown voltage using the linear algebra. Here's the example, a math of node analysis. How to determine V1, V2, and VT. The process are given. Application of nodal analysis, current analysis, filter design, and power system analysis. So we'll talk about the summary. Nodal analysis is a powerful technique that's offer a systematic efficient approach to circuit analysis. It is widely used to various field of electrical engineering, include the electronics, power system, and communication system. My second topic is Thevenin's theorem. What is Thevenin's theorem? Thevenin's theorem states that any linear electrical network with two terminals can be replaced by an equivalent circuit of a single voltage source VTH in series with a single resistor RTH. The simplification can make analysis complex circuit much easier. Why is it useful? Simplifies the analysis, facilities load analysis, aids in circuit design. Algorithm. Identify the load. Determine the component of the circuit that you who want to analyze. Remove the load. Disconnect the load from the circuit, leaving two open terminals. Calculate the Thevenin voltage. This can be done using various circuit analysis technique will like nodal analysis, mesh analysis, or source transformation. Calculate the Thevenin resistance. Deactivate uh, all independent source. Replace voltage source with short circuit. Replace current source with open circuit. Calculate the equivalent resistance between in the two terminals. Construct the Thevenin's equivalent circuit. Create a new circuit with a voltage source VTH in series with a resistor RTH. Reconnect the load. Connect the load to the terminal of the Thevenin equivalent circuit. Here is an example of Thevenin's theorem. How to define RTH, VTH, and RL. Process given. Advantage of the Thevenin's theorem: simplify a complex circuit for analysis, allows easy determination of current and voltage across a specific component, useful for analyzing power transfer and load variation. Real world application of Thevenin's theorem. Thevenin's theorem is a powerful tool in electrical engineering. Here are some real-world application: power system, electronics, telecommunication, and control system. My third topic is mesh analysis. Definition: mesh analysis is a technique used to determine the currents flowing through different branch at an electrical circuit. It involves applying Kirchhoff's voltage law to form equation based on the mesh currents. Key concepts: mesh, a loop that does not contain any other loops within it. Mesh current, current that circulates around the mesh. Kirchhoff voltage law, the algebraic sum of all voltage around any closed loop in a circuit is zero. Steps to perform mesh analysis: identify the meshes, determine the number of independent meshes in the circuit, assign mesh currents, assign a mesh current to each mesh in an arbitrary direction, applying KVL to each mesh. Write KVL equations for each mesh. The voltage drops across resistor and voltage source. Solve the equation. Solve the equation obtained in step 3 to determine the value of the mesh currents. Calculate the branch currents. Once the mesh currents are known, calculate the actual branch current by combining the mesh current, the flow thought of the. Here is an example of mesh analysis. Advantages of mesh analysis: efficient for planar circuits. It is particularly useful for planar circuit. Direct calculation of mesh currents. It directly calculate the mesh currents, which can be useful for certain applications: AC and DC circuit analysis, power distribution networks, and electronics circuit design. Thank you everyone for listening me.